Hello everyone. Here is an example video to help you with your third discussion in BA101. And in this video, we're going to use a video from YouTube from a channel called Basketball Stats, which contains information about the National Basketball Association, or NBA's all-time leader in three-point field goals made since this rule was put into place in time for the 1979-1980 season. Using the video, we're going to make a spreadsheet which tracks the top 6 leaders in three-point field goals made in their career from 1985 to 2020. For the sake of not making this a gigantic example video, we're only going to do 5-year intervals, so 85, 90, 95, etc. For each 5-year interval, we're going to determine how many new players have entered the list. So players, say for example in 1990 that weren't on 1985's list, in 1995, people that weren't there in 1990, who's new that made it into the top 6. After we've done this, we're going to find some data points. We're going to find the mean average of new entrants to the top 6 for every 5-year interval that we have during this time frame, the probability based upon the historical data that at least 4 new entrants have entered the list, and the complement of that, the probability that less than 4 new entrants have entered the list. And after we have all that information, we're going to use it to determine a few probabilities that 4 or more new entrants will enter the list in the following scenarios. The first is the NBA passes a new defensive rule that's supposed to make it easier for basketball players to make three-point field goals, and we believe that the probability of that passing is 0.800 or 80%. And the second one is, it is given that the NBA decided to move the three-point line back from its current distance of 23 feet 9 inches to a distance of 25 feet. We're going to assume that prior to this change, analysts believed that the following was true. They thought that the chance that the line was going to get moved back to 25 feet was 0.100 or 10%. And another analyst went through, looked at all the conditions that come with this and said that the probability that at least 4 new people enter this list and the line gets moved back is only 4%, which kind of makes sense when you think about it. If you got to shoot a deeper shot to make a three-pointer, you're going to have a pretty low probability of new people coming into the list if that passes. After we determined all this, our last step in here is to construct a 90% confidence interval to determine what 2 probabilities we are 90% confident advising someone that the probability at least 4 people enter this list during the upcoming period will be. And that's useful for things like advertisers. People are going to watch more basketball if there's people that are chasing all-time records. We want to tell an advertiser in this case that we think there's a certain percent chance that this is going to happen within the next 5 years, and hopefully doing so and being honest will increase our ad revenue. Could also be another thing like our vendors. Arenas have exclusive suppliers of adult beverages and food, etc. They're going to sell more if there's more people in the stands trying to watch a professional athlete chase history. So with all that being said, here is our video. And the video is just like the one that we've done prior. We're going to go through and we're going to grab every top 6 list, so the top 6 players in our charts right here, for every 5-year interval from 1985 to 2020. And the first one I would need is the in this case 84-85 season. So the NBA's season runs from October until like June, which means it actually wraps around a calendar year. I'm going to stop this video as soon as the second number hits the year that I'm looking for, and the first one is 1985. Save some time. I'm going to scroll through until I get to a spot that's close, and I'm going to hit play. And there we go. We have our, got a little bit of a stat going on there, Bill. There we go. We have our top 6 list going on over here. So what I can do is I can grab a spreadsheet and I can copy in who are the top 6 people. And I've already set the spreadsheet up to help me out in the process. Right here for 1985, our top 6, as we can see, are Hassett, Griffith, Taylor, Busey, Bratz, and Greavy. Top 6 players on the list. So I can just go and fill those names into the list. We've got Hassett, Griffith, Taylor, Busey, Bratz, and Greavy. And I move that off to the side again. get out of the way. And next year I need is 1990, so again, skip forward in the information a little bit till I get close. Right there looks pretty good. I'm going to hit play. And I'm going to stop this as close as I can to when it changes to 1989, 1990. There we go. And our top 6 for this list is Ellis, Bird, Ainge, Griffith, Hodges, Cooper. So let me go and bring my sheet back in, and I'm going to throw those names into the list. And we've got Ellis, Bird, Ainge, Griffith, Hodges, and Cooper. And I'm just going to keep doing this every 5 years until I have my full data set made. For the sake of not taking forever to make this video watching me write names in from bars, I've already completed most of this information over here. I went through and I grabbed the top 6 for every single period that I was asked to find information for. We have that information present listed here. The first thing we're asked to find is what is the average number of new entrants? Well, what's a new entrant? It's somebody that's on the list for this year that wasn't there in the period before. So here we can go through 1990 and see who's on the list that wasn't here the last time that we checked in 1985. Ellis, new name, so that's one new entrant. Bird, new entrant. Ainge, not here as well, new entrant. Griffith, oh, he was there, so he's the only so far holdover that we have. And Hodges and Cooper, they're all new entrants. So in 1990, 5 new people entered the top 6 and all time made 3-pointers. Let's do it again for 1995. We have Ellis, well, he was there. Ainge, he was also there. We have Adams, he's a new entrant. Adams wasn't here. We have Miller. Miller was not here last time. Porter, nope. And Price, also a new entrant, which means in this list there was 4. So these numbers on the bottom, I did that all the way through, tracking how many new entrants there was that weren't there the last time. So in 2000, 5 new people moved into the top 6. In 2005, 3 new people moved into the top 6. In 2010, 3 new people moved into the top 6. In 2015, it was 4. And in 2020, it was 3. And now we got all the information that we need to work with to start doing some calculations. So the first thing I'm asked to find is what is the average number of new entrants over this period? Well, all I can do here is I can just find the average of all of these numbers that I found. So I'm going to use the average function, type in equals average, and then I'm just going to grab that range of data. And we see right here that on average over this time frame, every 5 years, 3.857, so almost 4 players, move into the top 6 all-time in 3-point field goals made. What is the probability that there are 4 or more? It's typed weird, hold on. Probability of 4 or more, there we go, new entrants in our list during this time frame. Well, I can go through and I'm going to figure out how many of these different spots meet that condition, that they're 4 or 5, anything higher than 4. Going through right now, I can look at this information and see, just looking at it, that we have 1, 2, 3, 4 spots out of the 1, 2, 3, 4, 5, 6, 7. So our probability would be x over n, the number of returns we had that met the condition, which was 4, over the total sample size we have, which is 7 intervals. And that is 0.571. By the way, I should talk about why I didn't fill anything in here. There can't be a new entrant if this is the first year of the list. If you wanted to be super fancy right here, if you had a bigger set and you didn't want to go through and manually count it, you can have Excel help you out in doing so by using a combination of the COUNTIF and COUNTA function. So I'm going to start doing this out actually and do this the fancy way. I'm going to say that this equals the COUNTIF function. And we're looking for 2 different things here, the range and the criteria. Well, the range is that list of information that we had. So C8 to I8. The criteria that we have in this instance is it has to be 4 or more entrants. So anything greater than or equal to 4. And I'm actually going to type that in quotations to fill this in. So greater than or equal to 4. And I'm going to close that quote right there. And close the first parenthesis. So that should return to me, if I hit enter right now, 4, because that's how many we know meet the condition in here, and it sure is. But that's not the answer that I want because it's the probability I'm looking for. So I need to divide that by how many there are. And I can just use the count A function one more time to grab all that information. C1 and through C8 through I8. And I got the same probability right now, 0.571. Either way is fine with me. So what's the probability that there are going to be less than 4 entrants? Well, these two are exhaustive. We can only have 2 conditions, either 4 or more make it in, or less than 4 make it in, which means this would just be the complement of the probability of it occurring. So 1 minus that 0.571 is going to give us 0.429. If there's a 57.1% chance that 4 or more people enter the top 6 all time and 3-point field goals made, there's a 42.9% chance that they don't. The next thing that our assignment asked us for was the probability that 4 or more new entrants enter the list and these new defensive rules passed. Well, this is a joint probability because this doesn't happen all of the time. So there's a certain portion of this probability we're going to have where only 80% of the time this condition can ever occur. And then inside of that 80%, only 57% of that 80% of the time, we're going to have 4 or more new entrants. So how do I find the probability of F and D? Since it's a joint probability, I just multiply them together. F times D. And I'll make this just a little bit bigger so we can see it. There we go. F times D gives us 0.457. The next probability we're asked to find is the probability of F given 25. In that case, that is the probability of 4 new entrants given the fact that they're going to pass a rule that moves this 3-point field goal line back to 25 feet. Well, how do you find the probability of something given something else? What you do is you take the joint probability of both of those occurring, which would be F and 25, and then you divide it by the probability of what's given. Well, down here, another analyst, thankfully, already calculated this for us. We have the probability of F and 25 is 0.040. And the probability of 25 by itself is 0.100. So what I can do is simply divide the probability of both events occurring by the probability of what's given. And if the probability of F and 25 is 0.04 and the probability of the line moving back to 25 feet, or probability of 25 is 0.100, then the probability of F given 25 is 0.400, which means that should the line move back, there's only a 40% chance that 4 or more new entrants enter the list, way below our historical precedent that we already obtained from the data, which means that that 25-foot line definitely is going to lower the chance that future basketball players can make it that far up on this all-time list. The last thing that we're asked to do is construct a confidence interval for the range of probabilities that we have that 4 or more new entrants are going to enter the list during this upcoming period. Well, to do that, we need to construct a confidence interval. And the first part of the confidence interval we need is our Z critical value. Our Z critical value is the number that helps us quantify the chance that we make an error in this prediction. And to find it in Excel, you're going to use a function called, as soon as this loads, norm.inv, normal inversion. Hit go, and there's a few things in here. You want just the top one, norm.inv. I'm going to hit OK. And it's going to ask for 3 inputs: the probability I'm looking for, the mean, and the standard deviation. Well, the probability that you're looking for in this case is the probability that there's going to be a miss on one side or the other. We're going to make an interval. We're going to say the probability is between point X and point Y. How can we go wrong in that situation? Well, some of the time it's going to be on the low end. It's going to be less than X. If we're saying the probability is sometimes between X and Y, then the other way that we can miss and be wrong is the actual probability ends up being greater than Y, the high end of our guess. For the probability in this function, you want the probability of only one of those misses. So in this case, my probability is going to be 0.95. I know that might be a little bit confusing, but what we're saying right here is that if we're 90% confident that it's going to exist within a range of two numbers, then there's a 5% chance we think it might be low and a 5% chance it might be high. We only want to account for one of those tails, as they call them, one of the two different ways that we can miss. So in that case, there's a 5% chance that we're low and there's 90% chance that we're in the interval in between, then there's only a 5% chance left that our guess is going to, the actual probability is going to be higher than our range. So if you want to look at it this way, take your probability, your confidence level that you're looking for, figure out the complement of that, in which case would be 10%, divide that by 2 to get 5%, and add that to your confidence level, so 0.95. Now for the mean and the standard deviation, we can't really do that because this is a proportion. So when you throw this in, it's always going to be the same when you have a proportion question. The mean is going to be 0, and the standard deviation is going to be 1. And that comes out to 1.645. And once you do this for a while, at the different confidence levels, you'll come to memorize these numbers. So we'll practice, you'll get there. 1.645 is always the Z critical when you're working with a 90% confidence interval. What is the standard error at 90%? Well, to find the standard error, you get to throw in a very large formula over here. The standard error for a proportion is always equal to your Z critical value, so I'm going to click that 1.645, times, I'm going to open three parentheses, no sorry, I'm going to find the square root first, SQRT, and then I'm going to open three parentheses. And then it's going to be, in these parentheses, our proportion, or our probability of the condition we're looking for, and that is that 4 or more new entrants enter the list, times the complement of that, which you can put in as 1 minus that same 5.71, or if I wanted to, I could have just clicked the 0.429 because I know that's the complement of that number. Close two parentheses, and then I'm going to divide by the sample size, which I could do a count A function to do if I wanted to. I know it's 7. I'm just going to type in 7. So again, the formula to find standard error, it's equal to Z critical times the square root of your proportion or your probability times 1 minus the proportion of your probability, all divided by the size of your sample. And for us, we get a standard error of, I had a typo in there somewhere, 0.308. That is how much we think we're going to miss from the average that we're given by. So now I get to construct my confidence interval. And my confidence interval in this case is just our historical probability minus the standard error for our lower limit and our historical probability plus the standard error for our upper limit. So right here, I'm going to say this is equal to 0.571 minus our standard error of 0.308. And our upper limit is going to be our P bar, if you will, in this case the probability that 4 or more new entrants enter the list, plus our standard error for this confidence interval, which is that 0.308, and I come up with a range between 0.264 and 0.879. What does that mean? That means that we are 90% confident that when we roll around and we do this for 2025, the chance that 4 or more new people have entered this list in that year will be somewhere between a 26.4% chance and an 87.9% chance. That is such a huge range of potential right there. And I purposely grabbed some numbers in here that gave you a gigantic confidence interval. Why? Because working with data is not easy. You will have points where you go through and you do one of these techniques that you're going to learn in your studies, and the return that it gives you doesn't give you any real conclusive information. If we could say for certain that this was the number, it looks great if we're an advertiser trying to get, if we're the NBA trying to get new advertisers, with like the 88% chance that multiple people are going to be chasing history by joining this list. But we can't say that with any level of confidence it's going to be that high. We down here have a chance there's only 26% chance. Well, we can't in good faith go to an advertiser to tell them that hey, you should pay a whole ton of money to advertise during your games. There's a 26% chance something good's going to happen. It's not a very good chance, and it's part of the process. You're going to have a bunch of numbers that you crunch, and when you crunch those numbers, the results that you're going to get after you crunch them aren't going to give you a super conclusive answer. So working with data is fun, but sometimes it runs you around in circles. Have a good one, everybody.